Excellent. All right. Hello, everybody. This is episode one. Did episode zero last time. Episode zero, we just went ahead and set up the project. We are building a machine learning library in C++. Just right now, all the classical models is my plan. Uh, yeah, so where we are now, we have our static library set up. We have our little ML playground, and we have eigen set up for linear algebra. Uh, Kind of before we actually get into coding and all that fun stuff. I wanted to go over representing machine learning data and how do we actually represent a data set in code. So typically in Python, we have scikit-learn and we do like model.fit x comma y. But it's kind of like what is x, what is y, what are we doing? So we're kind of just building that out, kind of fleshing it out as an idea, and then we'll go ahead and to get in some code after this PowerPoint. I'm going to try to make this really quick. So we go with a table or a data set, and then we turn that into a feature matrix and a target vector. So say we have this data set, we have size, bedrooms, and prices. Some characteristics about this data set, it has three columns, it has four rows, or you could say five rows and a header. Um, right here, we just do a split into X and Y, where let's say if we have a model that we want to predict the price, we are going to take all the price values and we're going to separate them from the values we're going to use to make this prediction. So X can be defined as features we are giving the model to predict something. In this case, it's a size in bedrooms. And our target, which is Y, is what we're trying to predict. So what is target? Target is the price. We want to separate these into features, which is X, and target, which is Y. And yeah, every row in a data set or table, if you want to refer to as that, is a sample. So we have four samples here. Here's some convention. X is an R of X samples times the features, where the number of samples is equal to the number of rows, and the number of features is equal to the number of columns. So in our X data set, we have four samples with two features. Moving on to kind of why the shape matters, this is like the whole reason behind it, is if we want to get a prediction, we're going to have X, which is our number of features. We have W, which is our weights for the model, and then we have some sort of bias term. And so what we're doing is we're performing matrix multiplication, and we are doing broadcasting on this bias term. We will worry about that later on what that means. But we're doing X times Y, where X is the feature matrix and W are some sort of weights we have. And to do matrix multiplication, the column of the first matrix has to be equal to the row of the second matrix, and then that's how we get our Y prediction. So right here, if you look, we have 4 times 2, or 4x2 feature matrix times a 2x1 weight matrix. If we go ahead and multiply this, it's going to be, where the 2's are basically just going to go away, and then it's just going to be 4x1. When I say go away, they don't actually just disappear, but yeah, when you perform the matrix multiplication, you're going to end up with a four row, one column vector, which is going to be our prediction. And yeah, so going forward, this is what we're going to have to know. Observation example row, sample features are input variable or columns, target is our label, output or response, what we predict. And yeah, so moving into code, we are going to kind of simulate this. This is how it would look simulated into C++. So we create our feature column and we create our target vector, and then we can go ahead and do various stuff with that. And next, we're just going to go ahead into the coding, so I will see you there. Okay, so to start off, we're going to create the feature matrix X. If you recall in the slides, it was a matrix X that has four rows and two columns, where rows are samples. And columns are features. Make sure you include types.h right here, otherwise you won't have matrix. In this data set, we represented square footage and bedrooms. So we can go ahead and fill this out. We'll not do that. And then we had our target vector y, which represented the prediction prices for each house. So we'll go ahead and create that next. We'll go ML vector y, which is 4, and it's implicitly 1, so this is 4 samples, or 4 predictions, we could say. Or not predictions, 4 true. 4 house value prices. So many good names. And we'll go to populate this. So we have features X, and the model is trying to predict Y. We can do various printing operations using cout. And then Y as well. So you can just print X and Y. We'll make this capital. It should be capital just for consistency. So we can predict what this is. It's just going to print this in a nice format. So we can think of X as our data, and then Y is what we're trying to predict. So X contains the information we're given the model. Y contains the answer that we want the model to learn. We can access individual elements in this matrix and vector utilizing X and then your brackets and your corresponding location. So first row, first element, first sample, first feature. Yep. We can also do rows and columns if we wanted to. So std cout x.call of 0. Then we'll just print, see how all this works. Right here we have an error. Here, undeclared y somewhere. I was gonna say I see it, but I don't see it. There we go. So x, y, our first sample, first feature is 1200. And then our first feature is, of course, the square footage as we created in our column right here on line 13, our matrix. And after this, we want to go ahead and introduce something called like a weight vector. So if we remember from the slides, we had that formula of a prediction. If you recall correctly, it's the feature matrix X times some W, which is the weight vector, plus some bias term. We won't worry about the bias term for now, but we'll go ahead and create this weight vector. So I said weight vector, so we're going to call vector right here, and said it was weight, so we're going to call it weight. This weight vector has to have the same amount of columns as your X matrix does. So our X matrix has 2 columns, so our weight has to have 2 rows. We'll go ahead and randomize weights. We'll do 200 and 670. And then so what we said in the slides is we said y hat, which is the prediction, is equal to this feature matrix times this weight. So this is kind of simulating a prediction that the model could make. And then we could go ahead and print out our predictions. So this is kind of like a first glimpse of what a machine learning model does or is. So each sample is getting multiplied by the same set of weight vectors. And because we have these four samples, the operation produces four predictions. So a real linear regression term will have a bias term, and the weights will need to be learned from the data instead of just manually inputting them. But we're going to be doing that later. For now, we just wanted to understand X is the features, Y is the target, weights are the model's parameters, and then prediction is X times the weights. And so, yeah. So yeah, to close out, we establish how data is going through our library, our conventions. So rows are samples, columns are features, X contains the input features, Y contains the expected output. We went ahead and did a preview, how to implement it code. We still haven't taught the computer anything yet. We need some way of measuring how good our prediction is given we have our Y values, our target values. So that's the next thing we're going to learn is the error. How do we fix our error? How do we get an error? How do we understand how wrong our predictions are? So yeah, we're going to start building out the metrics section of the library. We can think of mean squared error, mean absolute error, root mean squared error. And after that, we'll be ready to move on to our actual first model, which is linear regression. Have a good one.